Section 5.7 on negative exponents in scientific notation. We're going to get a new property here, and we're going to think about that two ways. First of all, by writing out the factors and reducing, and by using the quotient rule. So for this first problem here, we're looking at x to the third over x to the seventh, and x to the third is x times x times x, and x to the seventh is x times x times x times x times x times x times x. Alright, and we know that to reduce, I'm going to cancel off x with an x, and an x with the x, and so on until I'm out of x's. And so that my answer here would be, well, I've canceled everything out of the top, so 1 over x to the 1, 2, 3, 4, so x to the fourth. Okay, which makes sense because we're going to cancel 3 of the top with 3 of the bottom, but it will leave us with 4x in the bottom. That's where there were more x's to begin with. But let's go ahead and use the quotient rule strictly. The quotient rule says that I'm going to subtract the powers. How would that work out? 3 minus 7 is negative 4, so it must be that x to the negative fourth is the same thing as 1 over x to the fourth. Okay. Now we prefer to write things without negative exponents, so we're going to be changing things that have negative exponents into quotients. X to the negative fourth power is the same thing as 1 over x to the fourth power. Alright? So for any exponent expression that's like b to the negative n, we'll write this as 1 over b to the positive n. The power becomes positive by writing it in the bottom. It's just a different way of writing it. A negative power in the top is the same thing as 1 over the power positive. Or vice versa. If it's 1 over b to the negative n, then that's the same thing as b to the n. Negative powers are like reciprocals. They're going to switch where the exponent expression goes. So let's see how this works. B to the negative fourth is the same thing as 1 over b to the fourth. Okay. Negative 6 to the negative 2 is the same thing as 1 over negative 6 squared. And I know what negative 6 squared is, so let's go ahead and finish this. It's 1 over a positive 36. Okay, 4 to the negative 3, that's the same thing as, that moves up here, so it's the same thing as 4 to the third over 1. I don't really need to write over 1 though, so it's the same thing as 4 to the third, and 4 to the third is 64. Okay, and it's going to move this up as well. That's the same thing as x to the 8th over 1, or just x to the 8th. Caution, be careful anytime you have coefficient negatives. A coefficient negative and a negative exponent are not the same thing. So let's just look at how these two examples work. This negative 2 power will move the entire negative 3 to the bottom and raise it to the positive 2 power. 1 over negative 3 squared is 9. Okay. In this next example right here, the negative 2 power, like any power, is very exclusive. It's only going to move the 3. So if it only moves the 3, it's going to leave a negative. Got to be a negative 1 there. And then once I've squared it, that 2 is positive down here, that's going to be negative 1 over 9. Okay. So negative powers, not to be confused with changing the number to a negative number. They're just moving it. Okay, the negative is separate and it's going to follow the same rules it always has followed. Okay. So in the next example, this negative 3 power is going to move this down to the denominator. Everything has its denominator. It was over 1 originally, so we're going to move this down to the denominator, make it 1 over negative 2 to the positive third power. Negative 2 to the positive third power is negative 2 times negative 2 times negative 2 is negative 8. And in the next one, the negative 3 power just moves the 2 down, so it leaves me with negative 1 over 2 to the third, negative 1 over 8. Okay, now these numbers are the same. Technically, actually, it's not simplified to leave the negative at the bottom, so we can stick it out front. And they're the same. They came out to be the same, but they're actually come about by a different method. They came out to be the same because there were an odd number of negatives here, 3 negatives that made a negative. But this problem only had 1 negative, and so it stayed negative. So all the answers are the same. The process and the work of showing how I got the answer is different. Alright, so what's going to happen in the next two here? This negative power is going to take the 5 and move it. So it's going to be 1 times 5 squared over negative 1. Or 1 times 5 squared is 25 over negative 1 is negative 25. Over here, the whole thing moves up to be 1 times negative 5 squared or positive 25. And these are different because if it's 2 negatives turned to a positive, 1 negative remains negative. Okay. So let's look at these examples. Okay. Just like in the case of the negative 5x squared, where the negative doesn't move, in this example here, the 6 is not part of the thing that has the exponent. So the 6 will not move. It's going to be 1 x to the 5th is going to move over 6. Now I don't need to write the 1 with the x to the 5th. I can just write x to the 5th over 6. Okay, that 6 has to stay in the denominator because the 6 itself did not have a negative power on it. It did not have that mover, that reciprocal negative power. Okay. So I'm going to move the x to the 8th into the denominator. Y to the 3rd, its power was already positive, so it's going to have to stay down there as well. There's nothing left on the top, so we need to put a 1 up there. That's it. Okay. On the next one, we're going to move the x to the negative 4th down and the y to the negative 8th up. Both of them had negative powers, so they'll both move. The 5 and the 2 are going to stay right where they're at. Those numbers did not have a negative power, so they're not moving. Okay. These are different letters, so I can't reduce them with each other. I can't reduce those numbers, so that's done. Right, and let's look at the last one here. Okay, 6 and 12 do reduce, so I'm going to call that 1/2. A to the 5th won't move. B to the 3rd moves to the bottom, and C squared moves to the top. When it moves, it becomes a positive exponent. And so I've written everything with positive exponents. The only thing I'm just going to do, and I rewrote it right here, is I don't need to write that 1 because there's other stuff on the top. So we're going to say A to the 5th times C squared over 2B to the 3rd. Alright, so here we've got a summary of all of the properties of exponents that we've seen in this chapter. The first property is the product property for exponents, and it says that you have x to the m times x to the n, that's x to the m plus n. Not to be confused with this property, which is very similar, x to the m to the n, which is x to the m times n. Notice the difference. In this first one, there are 2 x's with 2 different powers. In the second one, there was a single x with 2 different powers. Okay, so you can see the difference there. Okay. Next, we had the quotient property, and the quotient property said that I was going to subtract the powers. And then the raising a product to a property and raising the quotient to a property were these 2 rules that said if I had a product inside, both parts of that product are going to be raised to the n power, or a quotient, both parts of that quotient were going to be raised to the n power. Okay. Now we could add to that list the rule that we just learned. We just learned that x to the negative n power is 1 over x to the n. To be simplified, an expression can have no parentheses. In any monomial term, each variable appears as a base at most once. Each variable or constant appears at a base at most once. Each numerical expression, such as 7 squared, has been calculated, and each numerical fraction has been simplified, and each exponent has been, or is positive, has been changed to positive if necessary. So those are the things we need to make sure are done. So in this first example, there's actually two things to do. One is to remove the parentheses, and the next is to consider whether I have any negative exponents. I'm going to have both of those things. So to begin with, power to a power, those are going to multiply. We can see from above that's very similar to rule 5. Power to a power multiply. Okay, so that's x to the negative 18th. Can't leave it that way because I need to make sure my exponent is positive. So we're going to rewrite this by putting this in the bottom, making it 1 over x to the positive 18th. Now that is finished and simplified. Alright, now for the next one, there's multiplication to be done. So let's go ahead and do that multiplication. 4 times negative 5 is negative 20. X to the third times x to the negative 6th is x to the negative third. Now I got that because that's like the number 1 right here. When I have two different x's with different powers being multiplied together, I'm adding up their exponents. I have two different x's with different exponents being multiplied together, so I'm going to add up their exponents. Okay. Now anything that has a negative exponent is going to go into the denominator. Anything else is going to stay up top. That negative 20 does not have a negative exponent, so it's going to stay in the numerator, and the x to the third is going to go to the denominator. Okay, a couple more examples. The first thing I may do here is reduce that fraction. 30 and 10 would reduce to 3 and 1. Let me not write the 1 for a moment, because I might not need it since it's in the denominator. B to the third and b to the 8th. 3 of these will subtract off with 3 of those, and leave me with 5b in the bottom. That's where there were more b in the bottom. This has been reduced. No exponent is negative, so it's finished. 7/3 can't reduce. Okay, so let's look at the variables. We're going to take this and move it to the top because it was negative. So it's going to be x to the 4th times x to the 3rd, and x to the 4th times x to the 3rd. Those are going to add up to x to the 7th. Now notice that I could have done it in one step using the subtraction property that said that if I took x to the 4th minus the negative 3rd, it would get x to the 7th power. Okay, which is what I did end up getting. I just did it in 2 steps rather than 1. So it's definitely possible and very probable that you can use these properties. You can use different properties in different orders, and you'll arrive at the same answer depending on what property you start with first. So you might not start with the same property that I had chosen to start with. That's fine. You'll still arrive at the same answer. Okay. Alright, so on the next one, I have a couple choices. I could either deal with my negatives first, or I could deal with the parentheses first. It's up to you. Doesn't matter which way I want to start it. I'm going to go ahead and start by dealing with the parentheses. So I'm going to make sure that this negative 3 exponent gets displaced into both parts of that parenthesis. So I'm going to get 3 is raised to the negative 3rd power, and x is raised to the negative 4 to the negative 3. Those are going to multiply to a positive 12. Now I can't leave it this way because this needs to go into the denominator. It had a negative power, so I'm going to leave that as x squared over 3 to the positive 3rd power. And again, I can't leave it there yet. Remember, one of our other rules said that the variables had to be multiplied out. I had to figure out what 3 to the 3rd power was to be finally done here. 3 to the 3rd power is 27. 3 times 3 is 9 times 3 is 27. And we're done. Alright. In the next one, displace this power into both parts, or simplify first, then displace. Okay, so if we look at those two options, if I